All right, so on your paper, go ahead and write parabolas. And we've looked at parabolas before. What's another name for them? Starts with a Q. Quadratics, right? Quadratic equations give us parabolas. So we've talked about parabolas before, but we've talked about them in the context of quadratic equations. And when you do story problems with those, you can talk about things that are being launched in the air and then coming back down. You can talk about factoring parabolas and making them equal 0, and that's where we get like the quadratic formula and all that stuff. So when we talk about parabolas here, we're still talking about parabolas, but we're kind of looking at it in a different context. So if you look at the front of your packet that I gave you, you can see that a parabola is formed if you take the slice. See how there's two cones that are kind of like facing each other? If you take just a slice of one of the cones. So you're not slicing into both of them, you're just slicing into one. So when we look at parabolas right now, we're not ignoring the things that we've learned about parabolas before, but we're looking at parabolas and we're going to learn some new vocabulary about parabolas, and we're thinking about parabolas in the context of conic sections. Okay? So we're going to have some new vocabulary terms you probably haven't heard, and we're going to be looking at a form of the parabola that's slightly different. Like if you look down here, you can see two different forms of a parabola. This one is going to have an x squared, and you might even recognize that, x minus h squared. You've seen that before. But the rest of the equation looks different than what you've seen before. And then you probably have never seen y minus k squared. So what happens here is if you have a y minus k squared, it actually means the parabola has been flipped on its side. Instead of opening up or down, it opens left or right. Okay? So this right here, these equations that we're going to be using are equations you can use for parabolas, but people typically do not use these unless they're talking about conic sections. So the stuff that we're about to learn is only stuff you would learn if someone said, now tell me about conic sections and parabolas, and you go, okay, let me switch my brain over from how I normally think of parabolas to be thinking of them in this context instead. Does that make sense? Okay, so it's not going to contradict anything we've learned before, it's just slightly different. Okay? All right, so on your paper, first, just like for the other different conic sections, we're going to write the definition of a parabola and where it actually comes from. So a parabola is the set of all points in a plane that are equally distant. I just spelled equally wrong. Equally distant from the focus, which is a point, and the directrix, which is a line. The set of all points in a plane that are equally distant from the focus, which is a point, and the directrix, which is a line. Have you guys noticed that all these definitions have referred to distances between things?
Yeah, why?
I mean, it's a good question. I think these definitions are kind of hard to like mentally handle until you get into like super upper level math, and then it's like, oh duh, that totally makes sense.
I love how you like tried to change equidistant to equally distant, and then you actually spelled equidistant.
And then I started writing equidistant. Yeah.
Shut up.
Have you guys heard the words focus and directrix in relationship to a parabola before?
I feel like you mentioned it.
Yeah, we've talked about focus. Directrix is probably not something you've heard of before. So directrix is spelled like the word direct, and then RIX on the end. You guys got that? All right, so we're going to draw a little picture that we can refer to. So the part of a parabola that we're comfortable with is we have a U shape, and this part right here of the U shape is called the vertex. So we're comfortable with that. We've done that before. Mm-hmm. The parts that are new to this problem is that now up from the vertex you have a point called the focus. And then down from the vertex, the exact same amount is an imaginary line called the directrix. So I'm drawing it dotted. A directrix is not an asymptote. The reason we draw it dotted is because it's imaginary. The reason that we draw asymptotes as dotted lines is because they're imaginary. They're not actually on the graph paper. Like you wouldn't actually see them. So this right here is the directrix. So what the definition is saying is that you can pick any point on the parabola, any point at all, and this is not going to be very believable with my drawing because my parabola is not perfect, but it's saying that you can pick any point on the parabola, and if you measure this distance right here, it would be exactly the same as that distance right there. It's because my picture is not good. If my parabola was better, it would be believable. Or I could pick, did you say I was Picasso? Or you could pick this point right here and measure that distance, and it would be exactly the same as this distance right here. So that's what the definition is saying. If you look at a picture of an actual parabola, it is believable. Yeah. You get an A.
Oh, I like it more.
That's right. I get some support now. I get some support. Don't worry, guys. I got it. Okay. All right. We have a new, it's 2 words to describe something. I'm going to say it, and you're not going to giggle, okay? So, since I wrote on that picture, I'm going to draw a new picture. So, this is the focus. And when we draw these for conic sections, they will sometimes give you an intercept to draw, but most often not. So if we want to draw a parabola, we need more than just one point to draw a U-shaped graph. So the way that we get the other points is we draw this line. It goes straight through the focus. And then these are the points that we're going to draw as the end points of this.
Can you say the name, please?
Yeah, why are you so good? And the name of this line is the Lattice Rectum.
That is perfect.
I don't know who came up with that. Yeah. The name of this is Lattice Rectum. If you name your child first name Lattice, middle name Rectum, I'll give you extra credit. I mean, but it would be wonderful. So that line itself is considered to be a chord. A chord is a line that touches one side of a curve and another side of a curve. So it's called a chord. And the chord is parallel to the directrix. All right? So this line right here is called the lattice rectum. The points that we put on the parabola, those are called the endpoints of the lattice rectum. Okay? If you were going to giggle every time you say the word rectum, you may call it the LR if you want. Okay? So all right. So we're moving on. Ready? Moving on. Okay, so the way that the equations are going to look, you have 2 options. you have x minus h squared equals 4 times p, and we'll talk about that value and how it helps you in a second. So times 4 times p times y minus k. And this is the formula that you're going to be using if the parabola opens up and down, because the term that's squared is the x term, which is what we're used to with parabolas. Y equals x squared is like the most basic parabola you can think of. So if you have an x squared in the equation, that means that the parabola is like we're used to, and it goes up and down. Okay? So next to this, I'm going to write up and down. It would go up if whatever number is in this spot is positive. It would go down if the number in that spot is negative. Okay? The other equation we're going to look at is y minus k squared equals 4p times x minus, that's an x, times x minus h. And these parabolas go left and right. So if the value for 4p was a negative number, then it would open to the left. If the value for 4p is a positive number, it would open to the right. Okay? So we already know what the h and the k value are. What are the h and the k value? Not the center, they're for this type of problem specifically. They're for the vertex, okay? So if you look at the version that we're used to seeing, it goes HK. The other version starts on the right, HK. You guys see that? They're backwards of each other. So you have to be careful. The first coordinate of the vertex starts with the X. The second coordinate of the vertex comes from the part with the Y, okay? So for the first one, it's HK. For the second one, it's HK. It's a little bit backwards, okay? So the vertex is HK, just like normal. The part that we are not used to is the p value. We've never had that before. So the p value gives you two things, all right? So p is the distance from the vertex to the focus and the vertex to the directrix. So if you guys remember what I said the vertex was exactly in the middle of the focus and the directrix, or that the distance between the vertex and the focus and the distance between the vertex and the directrix is the same distance. So if you can figure out the p value, then after you graph the vertex, you can go up that amount and put the focus there, and go down that amount and put the directrix there. Or you can go left and right. Okay? So p is the distance from the vertex to the focus and from the vertex to the directrix. Right? Okay? Next, we're going to say 2 times p is the distance from the focus to the endpoints of the LR, or the lattice rectum, whichever you prefer to call it. Alright, so we're going to go ahead and get out that page of our packet, and we're going to adjust the drawing just a little bit because they put most of that in there. So as you guys can see in the drawing, here's your vertex. Your focus is up an amount of p, and the directrix is down the amount of p. We're going to draw a line that goes this way and put a dot right here. And draw this line going this way and put a dot right here. And we're going to label that this right here is 2 times p. So what we did is we just took the drawing in the packet and we added in the line that makes up the lattice rectum, and we drew the endpoints so that we know what other points we can draw on our parabola. Once we have 3 points, we we can make that U shape really easily. Okay. So whenever you guys draw a parabola, I expect you to have 3 points, and these are the 3 points I expect to see. Okay? All right, 2p. Okay, and then on the other picture, we're going to do the same thing. So this time we have a parabola that opens to the right. And what we're going to do is we're going to draw through the focus. We're going to draw that chord in there. And we're going to show that this right here is 2p. Yeah. Say it again.
So we draw the 2p.
Mm-hmm. It's 2p right here and 2p right there. You can label whichever one you want because they're the same.
I thought it was just a p.
No, they're the same.
So
Okay.
2p and p.
This is one value. This is double that same value. The p's are the same, but this one's just 1 and that one's 2. Okay. All right. So we're going to go ahead and graph one of these problems to start with. Now, the worksheet generator that I use to make your packets, it gives you the equations kind of backwards. It writes them like this instead. And so in the example problems, I decided to write them like this. But it hurts my brain to see them like that because I'm so used to seeing them flipped the other way around for conics specifically. So what I'm going to do is I'm going to have us start off with this because this is what your packet will look like. And then I'm going to go ahead and say that's really x plus 1 squared equals y minus 2 in parentheses. And if there wasn't parentheses around y minus 2 and there wasn't a number in front, what number really would have been there?
1.
1. Yeah, 1 is the only number you can put that wouldn't have made a difference if it wasn't there. Okay. So before we get started, let's go ahead and find the vertex, because that'll be helpful for when we graph it. Yep, so the vertex is -1, +2. Now, the 1 is in place of where the 4p shows up. So I'm going to write 4p equals 1. So if I solve that for p to figure out what that value is, then the p value is 1/4.
So always set 4p equal to the number in front of us.
Okay, so this is an x squared parabola. The 1 was positive. So your options were, since it was x squared, it could open up or down. The 1 was positive, so what does that tell you? Opens up. Okay. All right, so now we have enough information that we can draw the rest of it. Now, I would not draw this small because the p value is 1/4, which means we're going to be drawing 1/4. Okay, so that's going to be hard to draw if you make your picture really tiny. So my picture might be a little too big, so I'm going to go with it. Okay, so -2, 1 is right there. The reason my picture is too big is because my graph goes up like this. Okay, now we said that our graph goes up. And if you look at your packet, it needs to go up a length of p to find the focus and down a length of p to find the directrix. So we're going to go up 1/4, and there's the focus. And we're going to go down 1/4, and there's the directrix. So that's why I drew my picture big, because that 1/4 is kind of hard to draw. So here's my vertex. I went up 1/4 and I drew the focus. I went down 1/4 and I drew the directrix. Okay. Does that make sense? Up 1/4, down 1/4? I graphed negative 1, 2. Okay, so that means that the focus, my vertex was at the point negative 1, 2, and I went up a fourth. So what's the equation for, or not the equation, but what's the point for my focus? 2 and a fourth, yep. And the directrix is a horizontal line, so that's a y equals equation. And what's the y value if I started at 2 and I went down 1/4? 1 3/4. Okay. So now from the focus, I need to go left and right a certain amount to find the endpoints of the lattice rectum so that I can draw the rest of the parabola. So if the p value is 1/4, then what should 2p be? 2/4, which is 1/2. So from the focus, I'm going to go to the right 1/2, and I'm going to go to the left 1/2. And then my parabola connects the vertex with those endpoints. So the focus was at negative 1, 2 and 1/4, and I went to the left 1/2. So this was negative 1, 2 and 1/4, and I went to the left 1/2. So you have negative 1 minus a half. It's negative 1 1/2. Mm-hmm. 1 3/4. Mm-hmm. And then the other endpoint, I started at negative 1, 2 and 1/4, and I went to the right 1/2. So the y coordinate is still 2 and 1/4. The x coordinate was negative 1, and I went to the right 1/2. Negative 1/2. Okay, so those are the endpoints. Next, I'm going to go ahead and find the length of the lattice rectum. So I went left 1/2 and right 1/2. So what's that whole length? It's 1. And what you'll notice is that the length of the lattice rectum is always the number in front of the parentheses. It just has to be positive because it's a length. And the reason it's the same is because we went left 2p and right 2p. So altogether that's 4p, which is what the number is in front of the parentheses. Okay? All right, so the length is 1. One more thing that they sometimes ask for, they don't always ask for, but we can go ahead and do it, is the axis of symmetry. And you guys should be familiar with that. What's the axis of symmetry? It cuts it, yeah, it goes through the vertex, it cuts it right down the middle. So that's a vertical line, so that's going to be x equals negative 1. Yep. Okay. We're going to go ahead and try another one of those, but I wanted to show you guys a sideways parabola this time. Okay, so again, I'm writing it like this because the packet that I'm giving you has it written like this, but this makes me uncomfortable because it's backwards from the formula that is typically used. So we're going to go ahead and start this by switching it around. Because this flipped around version matches your packet. Not the packet of problems, but the packet of formulas and stuff. Okay, so when we find the vertex of this one, we have to be super careful because the x is over here and the y is over here. So what is the vertex? It's -6, 2. And 4p equals -4. So the p-value is -1. Yeah. P-value is 1. Now, if you look at this, we have a y squared, so that means we're either going to the left or to the right. Our parabola either opens left or right. But this is a negative, so which way does it open? Left. Okay. So we're going to go ahead and draw. We're going to go ahead and draw the vertex. Nope, don't draw a dot there. That was me being a bad example. Okay, so left 6, up 2, there's the vertex. And if the parabola needs to open to the left, and the p-value is 1, how should I draw my directrix and my focus? Yeah, so I'm going to go to the left 1, and there's the focus. And I'm going to go to the right 1, and there's the directrix. So it doesn't matter that the 1 is negative. The negative is just telling you, oh, it opens to the left. Okay? So once we know which way it opens, then we can say that that p-value is kind of like a positive p-value. So I can go ahead and write down what my focus is and what the directrix is. So this is the point -6, 2. I went to the left 1. -7, 2. Okay. The directrix is the vertical line x equals -5. -5, -6, -7, right? So this is x. And then from the focus, we have to go a distance of 2p in each direction so we can draw the rest of the parabola. Yep. And the p-value is 1. So how far am I going to go? 2. So I'm going to go up. I'm going to go up 2. And I'm going to go down 2. And then the parabola can be drawn using the endpoints and using the vertex. So the endpoints of the lattice rectum are, we're starting at -7, 2, and we're going up 2. Starting at -7, 2, and going up 2. That's 4, so -7, 4. And starting at -7, 2, and going down 2. -7, 0. Okay. So those are the endpoints. The length of the lattice rectum, we went up 2 and we went down 2, so what's the whole length? 4. And you'll notice that matches the number in front of the parentheses. It's just not negative because lengths are not negative. So the length is 4. And then let's go ahead and find the axis of symmetry. No, you're right, it is 2, but you have to but that's not exactly it. We have to include more information. Y equals 2. Good. It's a horizontal line. It cuts the parabola. All right. I'm going to give you guys, we have a packet about the same length as yesterday. I'm going to give you guys some problems to practice graphing it, finding all the things. And then just like yesterday, we have to go back and say, okay, if they give us these specific clues, what's the equation? Okay, so this is just going to be just like yesterday, all right? The more you goof off, the more homework you have, okay? So here, we're going to say find the equation of a parabola with the vertex of 2, 4 and a focus of 2, 5. So vertex of 2, 4, focus of 2, 5. So if I just draw a little sketch of what I have, that's going to help me a lot when I write the equation. So if I go over 2 and then up 1, 2, 3, 4, that's the vertex. And then they tell us that the focus goes up 1 from that. That's 2, 5. So if this is the vertex and this is the focus, then which direction does the parabola open? It opens, it's up and down for sure. And because we know the focus has to be inside of the parabola, that means this has to open up. So is our equation, since it opens up, is that going to have an x squared or a y squared? That's going to be an x squared. So as soon as I know that, I can go ahead and say, okay, the formula that I'm going to work with is x minus h squared equals 4p times y minus k. So I know that this is the equation I'm working with because my parabola goes up and down. Since my parabola goes up, is the 4p value going to be positive or is it going to be negative? Positive. It's going to be positive. Okay. So what should I plug in for h and k? 2 and 4. So I have x minus 2 and I have y minus 4. And then the p value is what? 1. You're right that we're going to put a 4 there. So this is a length of 1, and so that means in front I'm going to have 4 times 1, which is just 4. And that's the equation. I'm done. So remember what I said before, these problems are difficult because they make you think. It's not the same way every single time. So you have to be able to think through the problem and then work with it. The only reason they're difficult, I think, is because you do have to think. You can't just memorize it. But that equation was pretty easy to find once we thought about it. Right? Okay. So we're going to look at one more. We're going to find the equation. With the focus 2, 0 and Directrix x equals negative 4. So if you can't immediately see how the problem works, you should always draw a picture. Once you draw the picture, it makes things a little bit more clear. Is that Directrix vertical or horizontal? Vertical. So we have the point 2, 0. And then we have the Directrix is right there. So which direction does this parabola go? It goes to the right. So that means that we're using the y squared equation. So we have y minus k squared equals 4p times x minus h. And if it goes to the right, what does that mean for our p-value? It's going to be positive. It's going to be positive because it opens to the right. Okay. Can you guys tell where the vertex should be? So I've heard a few people say -1. Why are we saying -1?
Right.
It's got to be right in the middle. Okay? So the vertex is the point -1, 0. And if the vertex is -1, 0, what's the p-value? The p-value is 3. So remember, the p-value is how far the focus is from the vertex, or how far the directrix is from the vertex. So we have a p-value of 3. You can see 3 on either side. Okay. So we thought it through. We got those numbers, the vertex and the p-value, and now we're ready to write the equation. So we have y minus k, so what should I write there? Y minus 0 squared, which would give me just a y squared, right? Equals 4 times p. Yep, 4 times 3 is 12. Times x minus h. The h value is -1 plus 1. So there's our equation right there. Yep. So this is me showing my work to write the equation, and then this is after I simplified it. Okay. So the easiest thing to do when you're trying to write the equation is to draw the stuff they gave you. And all you need to write the equation is you need to know what formula you're talking about. Is it the x squared formula? Is it the y squared formula? And then you have to know if the for p value should be positive or negative. And you have to know what p is, and you have to know what the vertex is. Okay, so just a few things, and once you have those few things, then you can write the equation pretty easily. So the thinking comes in picking out which of those 4 things you have. Okay?